GeopByte.
Hi friends, welcome to the GeopByte. In this video, let us discuss the problems which were given in previous Ecet exams for the subject physics. In this unit, we are going to discuss the problems for the very first part of the physics is units and dimensions. Dear friends, from the units and dimensions, you can expect the 2 marks. 2 marks can be expected from the units and dimensions. In the last 2 videos, we have discussed some problems which were given in the previous exams. In this video also, let us discuss some more problems. Look at the very first problem. Look at the very first problem. The dimensional formula for angular momentum is the dimensional formula for angular momentum is, dear friends, angular momentum is equal to mvr, where m be the mass, v be the velocity, r be the radius. Mass dimension is capital M, velocity L by T, radius is the distance dimension, that is L. So you simplify this one, m L square T power minus 1. m L square T power minus 1 is the dimensional formula for angular momentum. Now look at the options. Option A, ml T power minus 1. No, it is not correct. Come to the B, ml inverse T inverse. This is also not correct. Look at the option C, m L square T power minus 1. Therefore, option C is absolutely correct. Option C is absolutely correct. I hope you got my point. Dear friends, this problem is very important. Already 2 times the same problem asked in the Ecet exams. Let us go for the next problem. Look at the second problem. Which of the following has not been expressed in proper unit? Option A, stress by strain is in Newton per meter square. Absolutely correct. Because stress by strain is the Young's modulus. Stress by strain equal to Young's modulus denoted by E. Since strain has no units, therefore Young's modulus unit and stress unit both are identical, that is Newton per meter square. Anyhow, the first option is maintaining the correct unit, but it is asked incorrect unit. Which of the following has not been expressed in proper unit? Incorrect statement you are asked to find. Anyhow, A is not our option. Come to the surface tension. Surface tension equal to surface force per unit length. The force unit is Newton, length unit is meter. Newton per meter is the unit of surface tension. The same is given. Therefore, option B also written with correct dimension or correct unit. Therefore, option B is not our option. Come to the third option, that is energy energy unit is joule. Joule means Newton meter. Joule unit is Newton meter. It means 1 joule equal to 1 Newton meter. Okay. Newton is the unit of force. Newton is the unit of force. Force F equal to MA. Mass is in kg. Acceleration in meter per second square. So the force unit is Newton. So Newton means kg meter per second square. That means 1 kg meter per second square is equal to 1 Newton. That means kg meter per second square is the family group of Newton. So in the place of Newton, let me write this one, kg meter per second square into meter. You simplify this value, kg meter square per second square. So energy unit in terms of kg meter square per second square. But what it is given? It is just given kg meter per second. Therefore, the unit given for energy is not correct. That is our correct answer. Therefore, energy is not given with the correct units. Option C is right. Option C is our option. I hope you clearly got my point. Look at the last one, pressure. Pressure equal to force per unit area. The force is in Newton, area is in meter square. Newton per meter square is the unit of pressure. Remember, pressure and stress both are maintaining the same units. I hope you clearly got my point. Let us go for the next problem. Look at the third problem. The unit of impulse is the same as that of. Dear friends, impulse means rate of change of linear momentum. Therefore, option B is absolutely correct. Rate of change of momentum is the impulse. Therefore, impulse and linear momentum both are maintaining the same units. Therefore, option B is absolutely correct. Let us take the next problem. Look at the fourth problem. If the force is given by F equal to AT plus BT square, where T is the time, the dimensions of A and B are. You are asked to find the dimensional formula for A and B. You know, F equal to MA. Dimensional formula M L by T square. It is equal to M L T power minus 2. So the dimensional formula for force is ml T power minus 2. Therefore, the AT dimensional formula must be equal to ml T power minus 2 and BT square dimensional formula must be equal to ml T power minus 2. Now let us simplify it. T is the time, dimension is T equal to m L T power minus 2. Therefore, A equal to m L T power minus 2 divided by T. So, A dimensional formula m L T power minus 3. That is the A dimensional formula. Come to the B. B into T square is equal to m L T power minus 2. Therefore, B dimensional formula m L T power minus 2 divided by T power 2. The B dimensional formula is m L T power minus 4. ml T power minus 4. So, A dimensional formula ml T power minus 3. B dimensional formula ml T power minus 4. Now look at the options. First option is not correct. Look at the option B. The option B, look at the A dimensional formula, m L T power minus 3. Okay. Similarly, B, m L T power minus 4. T power minus 4. Therefore, option B is absolutely correct. I hope all of you understood this problem. Dear friends, this problem also very important problem. Already 2 times the same problem asked in the Ecet. Therefore, I am marking this problem as the 5-star problem. 5-star problem means most expected problem. Most expected problem once again in the Ecet. I hope you got the information. Let us go for the next problem. Look at the 5th problem. This problem also very important problem. I can mark 5-star problem, means most expected problem. Let me read the problem. The dimensional formula of Planck's constant h is, dear friends, Planck's constant h equal to energy divided by frequency. Energy divided by frequency. First, let us make for energy dimensional formula. Energy unit is Newton meter. Newton is the unit of force. So it is force multiplied by distance or displacement. Force is mlt power minus 2. Distance is L. The energy dimensional formula ml square t power minus 2. That is the energy dimensional formula. Come to the frequency. Here frequency equal to number of vibrations for the given time. Number of vibrations divided by time. Vibrations has no unit, so indirectly it is 1 by t. It is equal to t inverse. Therefore, the Planck's constant dimensional formula, energy dimensional formula, ml square t power minus 2. So this is the energy dimensional formula. I wrote the same, divided by frequency dimensional formula is T inverse. You simplify this one for getting ml square t power minus 1. Therefore, the Planck's constant h dimensional formula ml square t power minus 1. Therefore, look at the option A, ml square t power minus 1. Option A itself is absolutely correct. I hope all of you clearly understood. Let us go for the next problem. Look at the 6th problem. Which one of the following physical quantity has the dimensional formula ml t power minus 1? Look at the dimensional formula for work first. A, work equal to force multiplied by displacement. So force dimensional formula ml square t power minus 1. Displacement is L. Dimensional formula ml square L cube, not L square, L cube t power minus 1. That is the dimensional formula for work. Therefore, the first option is not correct. Come to the power. Power equal to what? work divided by time. Work divided by time. Work dimensional formula ml cube t power minus 1 divided by t. Therefore, the power dimensional formula ml cube t power minus 2. So, it is also not correct. Come to the impulse. Impulse means change in momentum. Impulse. See impulse. Impulse unit is momentum. Momentum unit. Momentum equal to product of mass and velocity. Dimensional formula m L by t. It is m L t power minus 1. Therefore, the dimensional formula for impulse is equal to dimensional formula of the momentum, that is equal to ml t power minus 1. The given is ml t power minus 1 only. ml t power minus 1. Therefore, the given dimensional formula is for impulse. I hope you clearly got my point. Option C is absolutely correct. Let us go for the next problem. Look at the 7th problem. M L square t power minus 2 are the dimensions of. First option is force. Force dimensional formula. Force equal to MA. It is equal to M L by t square. Therefore, M L t power minus 2 is the dimensional formula for force. But given is M L square t power minus 2. Look at the option B. Option A is not correct. Moment of force. Moment of force means indirectly torque. Dear friends, torque is the product of force and radius. Force dimensional formula m L t power minus 2, that already got it. Radius is the distance dimension L. It is m L square t power minus 2. So m, given value m L square t power minus 2. Therefore, the given dimensional formula is absolutely for moment of force. Remember, moment of force means indirectly a torque. I hope you got my point. This is also important problem. Let me make the 5-star problem. 5-star problem means the most expected problem. I hope you got my point. Let us go for the next problem. Look at the 8th problem. Out of the following pairs, which one does not have the identical dimensions? Look at the very first option, moment of inertia and moment of force. Here, moment of inertia denoted by I is equal to mk square. K is the distance. M dimension is capital M. K distance dimension L square. ml square. This is the dimensional formula for what moment of inertia. Now come to the moment of force. Moment of force means torque only. Moment of force or torque. Moment of force is nothing but a torque. T equal to force multiplied by radius. Let me write it clearly. So force dimensional formula mlt power minus 2. Radius is the dimension. Radius is maintaining dimension. The distance of dimension into L. This is equal to m L square t power minus 2. So look at the moment of inertia dimension and the moment of force dimension both are differing. Therefore, the first option itself, moment of inertia and moment of force both are not maintaining the same dimension. Therefore, the correct answer is option A, because it is asked out of the following pairs which one does not have the identical dimensions. So the first one itself is not maintaining the identical dimensions. Therefore, option A is absolutely correct. I hope you got my point. Let us take the ninth problem. Look at the ninth problem. The dimensional formula of half mv square. Half mv square is the kinetic energy formula. Here mv square, m is the mass, dimension is m, v be the velocity, equal to L by T, but V square, L square by T square. So it is M L square T power minus 2. M L square T power minus 2 is the dimensional formula for half mv square. Look at the option B. Option B itself is absolutely correct. I hope you got my point. This is also important problem. Let me mark as 5-star problem. Let me mark as 5-star problem means most expected problem. Let us go for the next problem. Look at the 10th problem. Which one of the following physical quantity can be represented by Newton per meter square? Look at the very first option. Option A, pressure. Pressure general formula is, pressure may be denoted by P equal to force per unit area. Generally force is in Newton, area is in meter square. Newton per meter square or Pascal. 1 Newton per meter square equal to 1 Pascal. Therefore, the given quantity in Newton per meter square is the unit of pressure. Option A is absolutely correct. Remember, the unit of pressure and stress both are same. The unit of pressure, stress, Young's modulus, remains same. I hope you got my point. Let us go for the next problem. Look at the 11th problem. The SI unit of universal gas constant R is, dear friends, universal gas constant is equal to energy. Remember this relation, energy divided by temperature mole. Energy divided by temperature mole. Energy unit is joule. Temperature Kelvin. Mole is, let us write like this, mole. So it is joule Kelvin inverse mole inverse. That is the unit of universal gas constant. Joule Kelvin inverse mole inverse. Of course, it can also be written as, let me write clearly, joule Kelvin inverse mole inverse. Look at the option B. Option B is joule Kelvin inverse mole inverse. Therefore, option B itself is absolutely correct. I hope you got my point. Let us go for the next problem. Look at the problem, 12th problem. If the force is given by F equal to AT plus BT square, where T is the time and the dimension of A and B are, I think the same problem we have discussed as a fourth problem. The same problem has done, that means this problem has given 2 times. Very, very important problem. The same problem we have done as a fourth problem. Since this problem has done already, we have discussed as a fourth problem, you practice this problem. I am making this problem is a practice problem. You practice it. This problem is very, very important problem. Most expected problem. Most expected problem. Since already you have listened this problem as a fourth problem, you practice by yourself. If you find any difficulty, go for the fourth problem. If you have still doubts, you please send your doubts to GeopByte. Definitely I will answer for your questions within 24 hours. Anyhow, my dear friends, with this problem, I am concluding this video. You please practice all this problem once again. If you find any difficulty, please don't forget to send your doubts to the GeopByte for getting the answers. Anyhow, thank you for watching. Have a great day. Please subscribe our channel called GeopByte for getting the update information. Thank you. Thank you very much. Have a great day.
GeopByte.